All right, so we've pretty much covered all the content for this. Everything that will be on your chemistry exam we have covered. Today's worksheet, periods on the periodic table, is going to be kind of a review. You have some tables to fill in there with information like electrons and valence shells and family number, some multiple choice things or matching on the back, and then a little fictitious periodic table on the back. But I just want to do a quick little review here before I pass that out. You're going to complete that in class and we'll grade it in class. Again, remember that this periodic table might color code things a little different, but we'll still find the same elements in the same place. And we know that everything in this column is referred to as a noble gas. What makes it a noble gas? And what's unique about a noble gas? Melissa? Always? Give me a generalization that will apply to all the noble gases. You're right that this one, this one, this one, this one, and this one all have 8. They're always full. That outer electron shell is full or it has 8. Okay? Now, these have 8. I wouldn't say that they're full because they can actually take, some of these can take more than 8. But this shell, this second shell, the maximum it can hold is 8. How much can the first shell hold? 2. So this one is content. It has all it needs. How many electrons are hydrogen going to have? 1. What group is it in? First one. It belongs over here. So we look at the arrangement on that. It has 1. Is it content to be sitting that way? With just 1? No. So it tends to like to combine with what? Well, it could combine with a halogen, that's true. But what else would it like to combine with? Because remember, this doesn't want 8. This shell can't even hold 8. It can only hold 2, right? So it's looking to combine with something that has 1. You got it. It combines with itself. Remember I talked about how this element often occurs as H2? 2 hydrogens combining together, sharing an electron, will give them both 2 electrons. They share that other electron, so they have 2, and they're happy. Okay? But the rest of the halogens have that outer shell with 8. And that's our magic number that we'd like to have. Okay? Whether you have 1, 2, 3 shells, 4 shells, it doesn't matter. 4 shells, you'd like to have 8 in that outer one if you can. That's why these are stable. That's why they're inert. Okay, off the top of your head, what is this group called? Alkali metals. What's this one? How many valence electrons does this have?
2.
And this one?
1.
And this one?
8.
What are these called?
Halogens.
How many does it have?
7.
7. How many does it want?
8.
What would it like to combine with? So that it's 7 and 1 equals 8. Okay? These guys would like to combine with group number 2. Get it? So it's all a matter of whether or not they're going to be sharing electrons, losing electrons, gaining electrons. Sodium, Na, has how many valence electrons? 1. There's 2 options here. It can either lose this 1 electron, which pretty much eliminates that outer shell. This middle shell becomes the outer shell. So it can lose that 1 or it can pick up 7 so that this shell is full. Which is easier? Losing 1. So if we take this 1 away, that outer shell is gone. This becomes the new outer shell and it has 8. Likewise, chlorine, which it likes to combine with, what's easier? Gaining 1 electron or losing 7? Gaining 1. Therefore, it's going to pick up the 1 from the sodium, and everyone will be happy, and they'll be so happy with one another that they will be bonded for life. Get it? That's how they become a molecule. That's how they bond. Okay? Now, if you end up with an atom like this that has how many valence electrons? 4. What's easier, gaining 4 or losing 4? Same. So what is it going to do? Share. It'd be easier just to share with another atom that has how many? 4. Okay, you got the idea down. Now, I'm going to give you this assignment, and on it you're going to see something similar to this guy right up here. And for whatever reason, this is all stuff we've already done. This assignment should be total review for you. But people freak out. They look at that and they have no clue what to do with this table. Okay? When I say level 1, level 2, level 3, what's a synonym for level 1, level 2, level 3? Shell, or, well, not valence shell necessarily. Energy level, or orbit. Yeah. So I could refer to these as the orbits. If it is the outermost shell that has electrons, it's then called the valence shell. Okay? So all we have to do is know how to use the periodic table, know what the columns tell me, know what the rows tell me. Columns are called groups or families, rows are called periods. Guys, your ability to look at this thing and say, oxygen has so many electrons, so many protons, and so forth, knowing what the groups and periods tell you, knowing how many valence electrons, your ability to do that is like the equivalent of being able to do addition, subtraction, and knowing your times tables for math. Okay? You can't be expected to go into algebra class if you don't know how to do those basic things. Once you understand what the columns and the rows mean and what these numbers tell you, you use those skills every day in chemistry. And you use them so much that you have things memorized. You know without even looking up there that sodium is in what group? Without looking. Group, what number though? 1. So it has how many valence electrons? 1. And you'll even start to memorize some of these numbers too. The mass number and the atomic number, because you'll be checking the same ones up all the time. And you won't need to use your periodic table as much. But let's just do these two as an example, because I don't want you to get confused. Argon is number what? 18. It's over here. It falls into what group? What do we call these in this column? What kind of gases? Noble gases. So it's number 18. 18 tells me the number of what? Protons. Does argon always have 18 electrons? Not necessarily. But it always has 18 protons. Now, most atoms are neutral, therefore they have an equal number of protons and electrons. Tell me, calcium, how many protons? How many electrons? Sodium, how many protons? How many electrons? Hydrogen, how many protons? How many electrons? Do you know how many neutrons normally? 0. No neutrons. If I throw in a neutron, what does it become? It's It's an isotope, exactly. If I throw in one more neutron, excuse me, let me back up here. Back to this guy. Here's hydrogen, right? Look, 1 proton, 1 electron. If I throw in a neutron, is that going to change this number? No. Is that going to change this number? These two numbers are always the same. The atomic number is the number of protons. If I throw in a neutron, will it change this number? Yes. Okay? That number goes up. It's a different version of hydrogen, and it is called a isotope. Okay? So remember, that number is only about the number of protons. Now, if I were to be able to take a proton, throw it in there, and add a second proton, then what would it become? Helium. It would be helium. Okay? All right, let me go back to where I was here. So we know now what the numbers tell us. You can look at argon and you can tell me if it has 18 protons, how many electrons? 18. And we know carbon has how many protons? 6. It's right here. By the way, some tables will take these numbers and flip-flop them. So you have to make sure you look at the keys so you know which is which. So this has 6 for that one. All this is saying is, just like remember when we wrote out the electron configuration, dash, dash, dash? Okay, it's the same thing. You're just writing it in a table. So if we know that argon has a total of 18 electrons, we next need to know how many shells are they distributed into. How do we know how many shells or orbits argon has? The period number. This is period 1, period 2, period 3, 4, and so on. So how many shells? 3. Now it doesn't require you to write it on there, but I'm going to go ahead and do that. There are 3 shells. So there should be a number in each one of these. Okay? How about carbon? How many shells?
2.
Period 1, period 2. It only has 2 shells. So I'm only going to have 2 energy levels. There won't be anything here. So I can already fill that in with a number. 0. There's no electrons in that one. It's 0. By the way, if you leave yours blank, you're going to get it wrong. Okay? All right, so let's go back now to argon. Those 18 electrons are spread out into 3 shells. We already know how many are going to be in the last shell. What tells us that? The group number. And this happens coincidentally to be in group number 18. Okay, group 18 has how many electrons except for helium? 8. So there's going to be 8 in that valence shell, in that outer shell. And we already know that that first shell for every atom can only hold how many? 2. And we always fill that one up first. So if I've got 8 here and 2 there, that's a total of 10. And I need how many more? 8 more. So how many are going to be in here? 8. Okay? Now that one we did without even having to use this thing. Okay? When you get to complicated ones, when you get to bigger atoms, some of your metals, uranium, and so forth, being able to use this becomes helpful. In the simple ones, sometimes you don't have to do that. But in the more complicated ones, you'll find that that's very useful. I'll show you how to do that here in a second. Okay, carbon. 6 total. Some are going to be in this shell, some are going to be in this one. According to this little guide, we always start at the top and we follow the pink arrows. And all we have to do is ask ourselves, what's the total number of electrons? The total is 6, right? How many are going to be in the valence shell? Well, that was based on the group number. What group?
14.
So how many are in the valence shell? 4. So we already know that there's going to be 4 here. So that makes our math pretty easy. It has to be 2, okay? Again, I use some real simple examples here, but if it is more complicated, like let's say that I have, I don't know, 48 electrons in the atom, and it's in 5 shells. I go 1, 2, 3, 4, 5 shells. My 5th shell is going to have my valence electrons. Let's say that it happens to be in group number 17. How many is it going to have here? 7. Which leaves how many to fill these shells? 41. So now I have to figure out how the 41 go into these shells. And you simply keep a running total and circle the numbers as you add them up. Starting at the top, pink arrow, and following your way down. 2 plus 2 is
4.
plus 6 is
10.
then I go down here. Plus 2 is
12.
plus 6
18.
plus 2
21.
plus 10
30.
plus 6
36.
36. Now normally I'd go down here, but this one's already done because I already knew how many went in there based on the group that it was a part of. So then the next one I go to is this one. We're at 36, right? Am I going to have all 10 there? How many? 36? 5. Exactly. So I'm going to cross that out and I'm going to write 5. Do you see how all those numbers add up to 41? Yes? Okay. Now that I know the total it adds up to 41, all I got to do is just total up each row. 2 here, and then 8, and then
18.
then 6 plus 2 is 8, 9, 10, 11, 12, 13. Yep, 13. Just trying to help you guys out here. Okay? Sometimes this will have 18, but not always. Okay? You guys are used to thinking that just this shell is the one that's different, okay, from the maximum number. That's not always true. This one could be different too, particularly when you start filling up 6 and 7 shells. Then this thing becomes real important. And later on, when you take this in college and high school, not only will you be able to tell me, yeah, there's 18 electrons in that third shell, but you'll be able to tell me 2 are in this suborbital, 6 are in this suborbital, 10 are in this one, 5 are in 4D suborbital. Okay? You can tell me exactly where they are, what shape they're moving in. Okay? So that's the whole point of that. D suborbital.